Good evening, sir.
Okay, Ram, we'll start in 1 minute. Okay, so Ram, today we have two topics. One is center of mass, another one is torque. But to study torque, there's one topic that I would like to finish first. So you remember this equation, V equal to omega R, where V is your linear velocity, omega is your angular velocity, and R is radius. So if you will differentiate this equation on both the sides, so differentiation of V will be dV by dt, differentiation of omega will be d omega by dt, and R is your radius. So dV by dt is your acceleration, d omega by dt is angular acceleration alpha, and R is radius. So you have to remember this equation that A is basically equal to alpha into R, where alpha is your d omega by dt, A is your dV by dt. So please write down this equation that A equal to alpha into R. So suppose that this is center and the radius is R, and suppose a mass M is here, and suppose the mass is rotating in circle. Suppose the angular acceleration is alpha, then the linear acceleration will be A, and A will be given by alpha into R. So please remember this equation that A is equal to alpha into R. Any doubt in this equation? A equal to alpha R.
Sir, I didn't really understand the differentiation aspect of it.
So A is basically dV by dt. So acceleration is rate of change of velocity, and alpha is your d omega by dt. So alpha is basically rate of change of angular velocity. Ram, is it clear? Sure.
Yeah, it's clear, sir. Can you also write delta V by delta T also, or does it have to be dV by dt?
Ram, any doubt?
Yeah, sir. Does it have to be dV by dt, or can it be delta V by delta T as well? Or does it have to be dV by dt?
Okay.
Sir, can you hear me?
So remember, equations of rotational motion. Like how will you write equations of rotational motion? No, Ram, I'm not able to hear you here. The voice is not coming actually. Ram, you are not audible.
Sir, can you hear me now? Hello?
Maybe you can
Sir,
write
can you
down the
hear?
question, then I can answer it. Okay. So you want to use del omega. See, alpha can also be written to be equal to del omega upon del t. And it can be written equal to d omega by dt. No, del omega and omega is different. Del omega means change in omega, and omega is basically omega. So del omega by del t will be your average angular acceleration, and d omega by dt will be your instantaneous angular acceleration. Okay, now we have Like for rotational motion, the equation will be something like this. So omega will be equal to omega naught plus alpha t. Theta will be equal to omega naught t plus half alpha t square. And omega square will be equal to omega naught square plus 2 alpha theta. So omega is your final angular velocity. Omega naught will be your initial angular velocity. Alpha is your angular acceleration, and theta is the angle covered. Because in rotational motion, the particle is rotating, and in linear motion, the particle is translating. These equations are same like this equation, like v equal to u plus at, s is equal to ut plus half at square, and v square equal to u square plus 2s. So in linear motion, we basically have final velocity, initial velocity, acceleration, and displacement. And in rotational motion, we have on the place of v, we have omega, that is final angular velocity. We have omega naught, that is initial angular velocity. We have alpha, that is angular acceleration. We have theta, that is basically angle covered. And you can use this equation only when alpha is constant. You can use these equations when alpha is constant. The value of angular acceleration is constant. Suppose I give you a simple question like this, that suppose that we have a wheel. Suppose that we have a wheel, and the wheel is initially rotating with 2 radian per second, and suppose alpha is given to be 10 radian per second square. So my question is, find omega and theta after 10 seconds. So you have to find out like what will be the angular velocity after 10 seconds and what will be the angle covered in 10 seconds. So this is your initial angular velocity. So omega naught is given to be 2 radian per second, and your alpha is given to be 10 radian per second square. So omega will be calculated by this formula, that is omega is equal to omega naught plus alpha t, and angle covered will be calculated by this formula, omega naught t plus half alpha t square. So this is how you have to use this formulas of rotational motion. If you have any doubt in this, you can ask me now. राम, any doubt? शौर्य कोई doubt है इसमें? Unit. So alpha is 10 radian per second square, omega is radian upon second, and for theta, it will be radian. Any doubt in this? शौर्य कोई doubt है? Okay, so we'll move forward now. So our next topic is how to calculate torque. So how do we calculate torque? So remember what is torque. Just give me 1 second. Suppose that there is a mass m, and suppose if I apply a force on mass, then the mass will accelerate. So if we apply force on a mass, then the mass will accelerate and it will be in translational motion. Similarly, if on any body, suppose we apply torque. So if we apply force, then there is linear acceleration of mass. But if we apply torque, then there will be angular acceleration. So if we apply force, then there will be acceleration. It means velocity can change. Velocity can increase also, decrease also. If we apply torque, then there will be angular acceleration. It means the angular velocity can increase or decrease also. So how do we calculate torque? So the formula for torque is, so torque is basically R cross F, or we can write R F sine theta. Now I'll tell you like how to use both of this, like how to use both these formulas. I'll explain you now, but the unit of torque will be Newton meter. And the formula for torque is R cross F. You can also use this formula, or RF sine theta. You can also use the below formula. So I'll explain you how to use both these formulas. Like what is the meaning of R, what is the meaning of F, and what is the meaning of theta. So please write down both these formulas, then I'll come to how to use these formulas. Okay, so how to use these formulas now. Suppose that we have a hinge, and suppose from this hinge there is a rod of length L. Suppose we have a hinge and we have a rod of length L, and suppose I am applying a force F like this. So my question is, what will be the torque about point O? So my question is, what will be the torque about point O? So how to calculate torque? So torque is basically given by RF sine theta. So what is the meaning of R? See, you have to calculate torque about point O, and the force is being applied at this point. So what is the distance between the point about which you are calculating the torque and the point on which the force is being applied? The distance is L. So R is basically distance between the point about which you are calculating torque and the point at which the force is applied. F is basically how much force you have applied. And how to calculate theta? You have to extend this line, the line joining the both the point. So this will be your R vector and this will be your F vector. And the angle here is 90 degree. So sine 90 is basically 1. So torque is basically L into F. So this is your torque. Now if you have any doubt, you can ask me now. How torque is L into F? Ram, you have to understand this formula. Like what is the meaning of R, what is the meaning of F, what is the meaning of theta. So F is simple, like F is the force applied. So what will be R? So R is the distance between the point about which you are calculating torque and the point at which the force is applied. So you have to join both this point, and this distance will be L. So R is basically L, F is basically force. And how to calculate theta? So what you have to do is, you just have to extend this line, the line joining both this point, and you have to calculate the angle between this line and the force F. So this angle is 90 degree. So sine 90 is 1. So this is how the torque becomes L into F. Ram, any doubt? Or we can solve one more question. We can solve one more question now. Suppose I ask you a question like this. Suppose that we have a rod of length L, and suppose that you are applying a force like this, and suppose this angle is 60 degree, and suppose you are applying the force at midpoint. So this will be L by 2, this will be L by 2. So my question is, what will be the torque about point O? So can you try it? Like how will you find the torque? Surely try kar sakte ho? Then we can see whether you understood it or not. Just put the formula and try to put the values. So torque is basically RF sine theta. Try to find out R, F and theta and put the values here. So R is basically the point about which you are calculating torque and the point at which force is applied. So R will be L by 2. F is your force. Now extend this line. So the angle between this line and force is 60 degree and sine 60 will be root 3 by 2. So answer will be LF root 3 upon 4. So this is your torque. Correct order. Ram, doubt? Okay. So similarly, you can also get questions like this. You can also get some questions like this. Suppose that this is hinge and suppose this is a disc. Suppose this is a disc of radius r. And suppose I am applying four forces like four forces. Suppose one force is F like this, another force F like this. Suppose one force F is like this, and suppose one force F is like this. Okay, and suppose this angle is given to be 60 degree. So my question is, what will be the torque about center? So how to calculate torque in this kind of questions? Now, just try to understand like what I am doing. So there will be four torque. One due to this force, one due to this force, one due to this force, and one due to this force. So let us first calculate torque for this force. So torque is being applied at this point. So this will be R. This is F. And if you extend it, the angle will be 90 degree. So suppose this is torque number one. So torque will be R F sine theta. So R will be your radius, F will be your force, sine 90 is 1. So the torque will be R into F. And if you will see, this force will try to rotate the disc in clockwise direction. So this torque will be clockwise. Similarly, for this force F, let us calculate force due to this torque. So torque will be R F sine theta. So same, the force is applied at a distance R from center. So it will be R. What is the force? The force is F. Extended, the angle is 90, sine 90 is 1. And this will also be your clockwise torque. Similarly for this force. Now remember one very important concept. Suppose if I extend force and suppose the line passes through the center, then the torque due to this force will be 0. Suppose if you extend the line of action of force and suppose this line of action passes through the point about which you are calculating torque, then the torque of this force will be 0. Or from formula, if you want to understand this, then from formula we can also calculate. So formula is RF sine theta. Same, the force is being applied at distance R from center. The force is F, and what will be the angle theta? So if you will see, if you will extend this line, so this line and force is in this direction. So the angle is 180 degree and sine 180 is 0. So torque will be 0. And finally, for this force, I want to calculate torque. So how to calculate torque? Like, suppose for this force, the torque is tau 4. So it will be RF sine theta. So the force is acting like this. Join it. So this distance is R. So on the place of R, you can put R. How much is the force? The force is F. And what is the angle between R and F? So this is the angle. So this is 60. So this will also be 60. So this will be 120. And sine 120 is root 3 by 2. So this will be your torque. And this torque will be anti-clockwise in nature. So two torques are clockwise. One torque is 0. One torque is anti-clockwise. So you can add both this clockwise torque and subtract the anti-clockwise torque, and that will be your net torque. So if you'll ask me, sir, how it is anti-clockwise in nature, because if you'll see, this force will have two components, one this component and one this component. This component cannot apply torque, but this component can rotate the body, and this component will rotate the body in anti-clockwise direction. So this is your anti-clockwise torque. So this is how you have to calculate individual torque. And finally, we have two torque which are clockwise in nature and one torque which is anti-clockwise in nature. So this will be your net torque. Ram, any doubt? Then you can ask me now. शौर्य कोई डाउट है? It is clear? Okay. So this is how you have to calculate torque. Now remember one thing. If you apply force on any mass, then the mass will accelerate. Similarly, if you apply torque on any mass, then the torque will have angular acceleration. And the formula for torque is also equal to I alpha, where I is your moment of inertia. I is your moment of inertia, alpha is your angular acceleration, and tau is basically your torque. So now you have to remember moment of inertia of different bodies. Some bodies, I am writing it right here. Suppose an axis is passing through center of any road. Then about this axis, the moment of inertia will be ml square by 12. Suppose any axis is passing through side of any road. Then about this axis, the moment of inertia will be given by ml square by 3. Okay, so suppose if I ask you that I have a hinge like this, and suppose this length is given by L by 2, this to be L by 2. Suppose one force is being applied like this and another force is being applied like this. So my question is, what will be the angular acceleration of the road? So first, find out the net torque acting on the system. So remember, if you extend this force, then it will pass through the point about which you are calculating the torque. So torque of this force will be 0. For this force, the torque will be, so torque will be Rf sine theta. So from this point, this distance is L by 2, so R is L by 2. What is the force? The force is F, and F is in this direction, R will be in this direction. Angle is 90, sine 90 is 1, so torque is L by 2F. So torque is basically L by 2F. And what will be the torque? Torque is basically moment of inertia into angular acceleration. So now if you will see, the road will rotate about center. And if the axis is passing through center, then the moment of inertia is ml square by 12. So on the place of I, you can put ml square by 12 into alpha equal to L upon 2F. So L and L will cancel out. And from here, you can calculate angular acceleration. So this is how you have to calculate net torque and angular acceleration. Oh, Ram. Okay, you don't know moment of inertia. Okay. First write it down. I'll explain what moment of inertia is. Yeah, I'll go to the previous slide. Okay, now remember what is moment of inertia. See, suppose there is a mass m, and if you apply force on the mass, then the inertia will depend on mass. Like more the mass, then to move it, more the force need to be applied. Similarly, if you want to rotate a body, so if you want to rotate a body, then the inertia depends on two things, mass also and the dimension of body also. So for translation motion, the inertia only depends on mass of the body. But for rotational motion, the inertia depends on mass as well as where is the mass located. So moment of inertia combines both these factors. So inertia in rotational motion is called as moment of inertia. So inertia for rotational motion is called as moment of inertia. So suppose if we have a road of mass m, length L, Then if an axis is passing through center, then about this axis, the moment of inertia will be ml square by 12. And if an axis is passing to the side, then the moment of inertia will be ml square by 3. Similarly, I'll send you a list of all the moment of inertia that you have to remember. Please note down all those moment of inertia. Yeah, is there there's a formula. I'm coming to that point, like how to calculate moment of inertia. So remember, moment of inertia is calculated about an axis. So moment of inertia is always calculated about an axis. So suppose that we have a mass m placed at r distance from an axis, then the moment of inertia of this mass will be m into r square. So moment of inertia is basically mass multiplied by square of distance of mass from the axis. So moment of inertia of any mass placed at perpendicular distance r from axis is mr square. So mass into square of distance. So suppose I asked you that this is your axis, and suppose we have two masses. This is your axis, and suppose we have two masses. One mass m placed at distance r, another mass m also placed at distance r. So my question is, what will be the moment of inertia about this axis? Now remember that there will be two moment of inertia. So this mass is placed at distance r, so moment of inertia will be mr square, plus this mass is also placed at distance r, so moment of inertia will be mr square. So net moment of inertia will be 2mr square. So this is how you have to calculate moment of inertia. So moment of inertia is basically mass into square of distance of the mass from axis. So this is how you have to calculate moment of inertia of any mass about any axis. So suppose I ask you this question. Suppose that we have axis. Suppose that we have an axis like this. And suppose we have four masses placed like this. Suppose one mass m is here, another mass m is here, another mass m is here, and another mass m is here. Suppose this is placed at distance r from axis. This is placed at distance r from axis. This is placed at distance 2r from axis. So my question is, what will be the moment of inertia about this axis? Try to find out. Okay, sorry, I'll just check. Okay, so let us calculate. For this mass, the inertia will be mr square. For this mass, the inertia will be mr square. This mass is on axis, so moment of inertia of this will be 0, because moment of inertia is basically mass into square of distance from axis. But this mass is placed on axis only, so inertia of this mass will be 0, and this mass is placed at distance 2r from axis. So moment of inertia of this will be m into 2r square. So this will be mr square plus mr square plus 4mr square. So it will be 6mr square. Okay, this is how you have to calculate moment of inertia. So now some moment of inertia you have to remember. Like suppose that we have a hollow sphere, and suppose mass is m, radius is r, Then about an axis passing through center, the moment of inertia will be 2 by 3 mr square. Similarly, suppose we have a solid sphere, and suppose an axis is passing through center, the moment of inertia will be 2 by 5 mr square. So there are some 12, 13 moment of inertias that you have to remember. Okay, I'll send you a list like which are the moment of inertia that you remember before exam. So you have to remember all this. But 2, 3, I am just writing it down. So please write for hollow sphere this, for solid sphere, this will be the moment of inertia. Similarly, suppose, write it down, write it. Okay. Similarly, to remember that, suppose that we have a ring. Suppose that we have a ring of mass m, radius r, and suppose there is an axis passing like this through center of ring. Then about this axis, the moment of inertia will be mr square. And similarly, suppose I have a disk. Suppose I have a disk of mass m, radius r, and suppose an axis is passing like this through center of the disk. Then moment of inertia will be mr square by 2. So you don't have to get into the intricacy of how we have arrived to this equation, but you have to remember the moment of inertia of disk and ring. So if an axis is passing through the center of ring, then moment of inertia will be mr square. If the axis is passing through center of disk, then the moment of inertia will be mr square by 2. Okay, so Ram, any doubt in this? Because you have to remember all this, yeah.
No doubt, sir.
हाँ शौर्य, देखो कि याद को शौर्य सारे याद है, बाकी सारे मोमेंट ऑफ इनर्शिया. Okay, now suppose there is a question in the exam like this. Suppose that we have a hollow sphere, a solid sphere. Suppose that we have a solid sphere that can rotate about center. We have a solid sphere of mass m, radius r, and suppose that I am applying a force like this on this sphere. So my question is, find alpha. So what will be the angular acceleration alpha? Find alpha. So what will be the angular acceleration alpha? Ram, can you try? So to calculate alpha, first you have to calculate torque. So torque will be given by Rf sine theta. So how to calculate R? So R will be this distance. What is F? So F is force. And what will be the angle? So this angle is 90 degree, sine 90 is 1. So this is your torque. Now torque is basically equal to I alpha. So in the place of torque, you can put I, but this is solid sphere. So moment of inertia will be 2 by 5 mr square. into alpha equal to r into f. So r and r will cancel out. So alpha will be equal to 5f upon 2mr. Solid sphere assuring. Ram, any doubt in this?
Clear, sir.
Yeah, I'll send the PPT. You have any doubt in this question? Like how to calculate
No,
torque?
sir.
Then you have to put torque equal to I into alpha. Moment of inertia you have to
Okay.
remember. From here you can calculate angular acceleration alpha.
It's clear, sir. Yeah.
Okay, so this is how you have to calculate angular acceleration alpha in this question. Now, there is one very important another thing, that is how to calculate angular momentum. Like we have linear momentum. Remember, suppose that we have a mass m moving with velocity v. Then we have linear momentum given by mass into velocity, and we can put direction I cap. So I cap will represent that the mass is moving in positive x direction. Similarly, if a mass is rotating, then we can calculate angular momentum. So angular momentum is calculated by this formula. So L is basically equal to R cross P, or we can write it to be RP sine theta. So L is your angular momentum, P is your linear momentum, and theta is your angle between r vector and p vector. So L is r cross p, or we can write rp sine theta, because a cross b is ab sine theta. So cross product of two vectors is ab sine theta. So r, p and sine theta. So I'll explain you like how to use this formula. Suppose that, please write it down. Please write down this formula. Ram and Shaurya, can you again join this meeting after? This class will get over in like 2 minutes. So you to join again by clicking on the same link. Ram, is it okay with you?
Sir, yeah, it's free, sir. It's fine. I have to go at 7:30 though. I have another call.
Okay. So we'll complete this topic like angular momentum on all today. So angular momentum is basically r cross p, or we can write rp sine theta. Yeah, Ram, I'll complete this topic and I'll end the class. Okay, so how to calculate angular momentum now? Suppose that it is given in the question that we have a mass m moving in that direction with velocity v. And suppose this is your O origin, and suppose this distance is given to be y. And my question is, what will be the angular momentum about origin? So angular momentum is rp sine theta. So now how to calculate r, how to calculate p, and how to calculate theta? So remember, r is same. R is the distance between the point about which you are calculating angular momentum and the point at which mass is there. So this distance is y, so r will be y. So what will be the linear momentum? Linear momentum is mass into velocity. And what will be theta? So you have to extend r, same. you have to extend r, and the angle between r and P will be your theta. So sine 90 is 1. So linear angular momentum will be mvy. So this is your angular momentum about origin. Please write it down.